Let's talk about the product rule now. This is a very important rule. It has to do with how do you find the derivative of a product of two different functions. So let's say we have f of x times g of x, and we want to find that derivative. Maybe your intuition might tell you that it's equal to f prime of x times g prime of x. Because remember when we did that sum rule, if we had f of x plus g of x, and we wanted to find the derivative, it was just the derivative of the first one plus the derivative of the second one, right? So based on how that follows our guess of what it would be, maybe we would also guess that the derivative of a product would be the product of the derivatives. But that is not true. If you do that, you will make mistakes. So we have to actually use it's actually a more complicated formula than that. It's going to be, well, let me just erase this. Okay, this is what it is. It's the derivative of the first one times g of x just left alone plus f of x left alone times the derivative of g of x. Now that's a little bit surprising. On your first time you would see that, you definitely wouldn't guess that would be the way it works, but that is true though. We do have a video later on which is optional, and if you want to see the proof of this, you can see how that actually comes about. But if you want to just accept it, that's perfectly fine as well. So let's do some examples to see how this goes. Let's say we have a function like, let's do this. How about something like this? Let's say we got x cubed times x to the power of 5, okay? That's a product, isn't it? You actually don't even need the product rule to do this derivative, right? Because remember, what if we just multiply these out? We would get x to the power of 8, and then the derivative of that, according to the power rule, would be 8x to the power of 7, right? So, but how about we try it again, but this time let's actually try to use the product rule, okay? So I hope I'm not confusing here. I just wanted you to see that this particular one you could do this derivative with the tools that we already have. But let's try it with this new rule here, the product rule. So think of this first term as f of x, and this second factor here is g of x. So let's follow the rule. It's the derivative of the first one. So the derivative of x cubed times x to the 5, left alone, plus, now we're going to leave x cubed alone, and then times the derivative of x to the 5. Now let's do it. Derivative of x cubed is 3x squared, and that I'll just recopy. And here is x cubed, and the derivative of this is 5x to the power of 4. Now let's simplify this. The 3 just stays there. X squared times x to the 5 is x to the 7 plus, and this, when I multiply this out, I get 5x to the 7. And when I add these up, I get 8x to the 7. And that's exactly the same answer as I had up here, right? Now you may say, why on earth would you want to go through all this work when you could just do it like this, right, and get the same answer? And I agree with you. Yeah, if it's this kind of a simple question, then you don't even need the product rule. You can just simplify this to x to the 8 and then use your power rule. But here's the point. Let's say I give you a different example. Let's do this one now. Say I want to find the derivative of, say, x cubed times sine x. That's a product, right? The first factor, f of x, is x cubed. The second factor, g of x, is sine x. Now, you know what? You have to use the product rule here. There's no way else to do it, because this function is already simplified. You can't simplify it any further, and there's no way to do this derivative unless you use the product rule, okay? So let's do it. It's going to be the derivative of the first. I should actually maybe go to a new sheet here. Well, I'll try to squeeze it in. So the derivative of the first term, first factor, is derivative of x cubed times sine x left alone. That's corresponding to right here. And then plus. Now I leave the first factor f of x alone. So I just write x cubed. And then multiply by the derivative of the second factor, sine x. And now let's actually do the derivatives. The derivative of x cubed is 3x squared. And then sine x is multiplied right after that. Plus x cubed is left alone there. And the derivative of sine x, as we talked about before, is cos x. So that's the right answer. That's that this derivative, we actually needed the product rule, right? There's no other way to do it. Whereas this one, we kind of had an option to fall back on our previous methods or to use the product rule. So, but the truth is, this one is so simple, you won't really ever be asked that. You're going to be given questions like this where you have to use the product rule, okay? So let's try another one. 1 second here. Let's do this example. How about we do the derivative of sine x times cos x? What is that going to be? That's a product, right? F of x is sine x, g of x is cos x. So it's going to be the derivative of the first factor times the second factor left alone plus the first factor left alone times the derivative of the second factor. And later on, you're going to just skip this step and go directly to the step I'm about to write here. But I'm just going a little bit slow since we're first introducing this concept. All right, the derivative of sine x is cos x. This cos x, notice there's no prime symbol on this cos x, so there's nothing to do. You just recopy it. Similarly, there's no prime here, so we just recopy the sine x. And this cos x is actually, the derivative of cos x, remember, is minus sine x. So notice now there's no more prime symbols. So we're done the derivative. Maybe we should simplify a little bit. Cos times cos is cos squared. This minus sign can be brought out here. And sine times sine is sine squared. And we can just leave our answer like that. All right? So we can... Notice we can do a question like this maybe. Say x squared plus sine x times root x minus cos x. How about we want to find the derivative of this? I know it looks a little bit scary maybe. Let's try that. But this is a product, right? Think of this here as f, right? And think of this part here as g of x. I'm going to erase that, though, because it looks kind of messy there. Don't need that. But that's what you should be thinking, okay? And notice when we do the derivative of this, we're going to be using the sum rule. And when we do the derivative of this one over here, we're going to be using the difference rule. So we're going to have to get used to combining all the rules of derivatives when we calculate more complicated derivatives. So let's see how this goes. This is a product rule. This is a product, so we need to use the product rule. It's going to be the derivative of the first factor times the second factor left alone plus the first factor left alone times the derivative of the second factor. Okay? Now, how do we find the derivative of this first factor? Well, it's a sum, right? So we do the derivative of the first plus the derivative of the second. The derivative of x squared is 2x. The derivative of sine x is cos x. This factor we just recopy. No, the derivative symbol is not there, so we don't need to do anything. We just recopy it. Recopy this one. And now we have to do the derivative of this. Well, it's a difference, so we're going to do the derivative of this minus the derivative of that. What is the derivative of root x? Well, we've memorized that. It's 1 over 2 root x. And minus, the derivative of cosine is minus sine, right? So I could write minus sine x here. But this minus and this minus just make a plus, right? So why don't I just quickly write that in to make that a little bit more, just to prevent myself from having to write that whole thing all over again, just to change that into a plus. Okay, so that's the answer, okay? And you don't have to simplify that. If you multiply that all out, nothing much would really happen. You might get some simplifying, but right now we're just focused on trying to use that formula, okay? So that's basically the idea. Maybe we'll just try one more here. Let's say we have something like, I don't know, 3 sine x minus 5x squared plus 3 times 2 cos x minus 1. That's a product. And the question is to find the derivative of it. How do we do it? We're going to use product rule, right? So let's apply our product rule. We're going to do the derivative of the first one. Actually, you know what? I wouldn't mind trying to do this one a little bit faster. You know, on these last questions here, you see how I included this step right here? One second. When I included this step right here, it's kind of, it's perfectly fine to write when you're starting out, but it would be nice if we could skip this step and just go directly to this one, right? Similarly on this one, this step here can be skipped as well. It's perfectly fine if you understand things just to go directly to this. Let's try to do that on this one, okay? So the product rule says we got to do the derivative of this first and then times this one left alone. Let's do that. What is the derivative of that first factor? The derivative of that first factor is going to be 3 cos x minus 2 times 5 is 10x plus 0, right? The derivative of 3 is 0. So I won't even include that, okay? So this is like f prime of x. The rule says next I multiply by g of x left alone. So I'll do that. And then plus, now I leave this factor alone. And I multiply then by the derivative of this second factor. What is the derivative of that? Well, it's 2 times negative sine x minus 0, right? The derivative of 1 is 0. And 2 times negative sine x, that's just the same as minus 2 sine x, right? So why don't I just make that little switch there to save a little bit of time. So it's just minus 2 sine x, okay? So that's basically the product rule, okay? Just remember that when you do the product rule, you have to, it's not the derivative of the first times the derivative of the second. It's not that simple. You gotta use this formula right here, okay? So I hope that's clear. The next rule we're going to talk about is the quotient rule, and then we'll do a lot of practice to get comfortable with these topics, with these new formulas, okay?